this is Dr. Bauk, and today I'm going to talk with you about dimensional analysis, or converting units. This will show up a whole bunch, especially in chemistry, and the strategy that we use here will be very helpful when you get to other things, not only converting units, but also when we convert between chemical compounds in a reaction. We're going to use the same strategy. So you may have a different way of converting between units, and good for you, but hold on to that. Please try to use this method so that you can get accustomed to this strategy, and when we use it for other things, you'll save yourselves a lot of work. Okay, so the things that I hope you get out of today is to be able to distinguish between a number or dimension, unit, and a direction, especially for physics. It's very important that those three things are going to go together. Obviously, to be able to convert between units, and importantly, to be able to use a strategy to convert between units. Okay, in science, numbers mean all sorts of different things. So we can have a number 12 that can mean all sorts of different things. So I can have 12, and I could have 12 pounds of watermelon. I could have 12-ounce can, or I could have a jogger that's going at 12 miles per hour. So almost always we're going to have some sort of unit that's going to be associated with the numbers that we use in science. And those units vary quite a bit. So we have a lot of units that have sort of accumulated over the years. And just looking at mass alone, we have the pound, we have a slug, which is about 14 kilograms. So we have the ton, we have a kilogram, we have atomic mass units, we have the Planck mass, we have solar mass. All of these units are still used today within different amounts of, well, except for the slug, it's still used today to describe the mass of something. And invariably, we want to convert between these two. So we may want to add together a pound and a ton, and we'll need to figure out how much that is altogether. Importantly, these numbers are going to be connected to units. So we call this a magnitude. Magnitude is going to be the number itself. So 125 meters of spaghetti, I have the magnitude of that is 125. The unit is meters. I may have 37.6 seconds that it will take for the next commercial to complete. My magnitude, my number is 37.6. My unit is seconds. I may have the number 154 foot-pounds of tensile strength. Here I have a compound unit, so more than one unit smashed together. That's fine. We're going to see a lot of this, especially when we get to energy and joules. But my magnitude is 154. My unit is foot over pound, so it's a compound unit. It's more than one thing there, and this may be a tensile strength. So if I have 12.5 vats of lard, my magnitude is 12.5. My unit is going to be vats. If I have 136 eyes of newt, I will have a unit of eyes. In physics, quite a bit, we're going to add direction into this as well. So we're going to make a vector out of this, which is going to have magnitude, unit, and direction. So all three of these things will stay together. For instance, I may have 48 steps to the north. So my magnitude is 48, my unit is steps, and my direction is to the north. Now these are all going to stick together. These are going to be intimately tied. We're not going to move them away from each other in any of our equations. All we can do is cancel them. And that's what we're going to do. So we're going to try to worry about canceling our units to make more sense out of it for ourselves. Okay. So how do we want to do this? Well, we have to know something to begin with. So let's start with a problem. So suppose I have 1.34 kilograms, and I want to know how many grams are in that. Well, I have to know something to begin with. I have to know how many grams are in a kilogram. And some of these things you will just simply need to know. So kilograms, milligrams, micrograms, centigrams, you should know those. Okay, so I'm going to start with something. I want to make sure I write this relationship down to begin with. So I'm going to start with my relationship. I know that 1 kilogram is equal to 1,000 grams. I have to get this relationship correct, or else I will not get the right answer to my problem. And it's good to think about this. So think about this. So a kilogram is bigger than a gram. So I should have more grams in a kilogram. I have to get this number correct. Okay, from this point, all it is math. So we're going to do some simple math. If I wanted to, I could divide both sides by 1,000 grams. In math, when I divide anything by itself, that cancels, and I'm left with the number 1. So I have a fraction. 1 kilogram over 1,000 grams is equal to the number 1. And I could have done the reverse. I could have divided both sides by kilograms. I would have ended up with the inverse of that, which is 1,000 grams over 1 kilogram. This is equal to the number 1. So I'm going to take advantage of this, that I can multiply anything by 1, and it's still the same thing. And that's what I'm going to try to do with my dimensional analysis. So I'm going to take what I started with, what I was given. I always start with what I was given. I want to make this into a fraction. I can put it over 1 just to make it look nicer, make it a little bit cleaner. And I'm going to multiply this by the number 1, but I'm going to be careful about which number 1 I choose. I'm going to try to select kilograms that will cancel. So if I use this relationship, where I have 1,000 grams divided by 1 kilogram, I'm multiplying what I started with by number 1, but now my kilogram units will cancel. And I'm left with the unit that I wanted, which was grams. And I can do the math now and figure out that this is 1,340 grams. You may have been able to do this in your head, or you may have wanted to do it by moving decimal points, as you may have been taught in earlier grades. That's a reasonable way to do it if this was your only problem. But remember, the point of this is to give you a strategy that you can use for other things as well. And this is the strategy. So the strategy is worrying about setting up fractions so that the units cancel. And if your units cancel, you'll end up getting the right answer. Okay. So let's try something a little bit different. So there's still still used today. You may hear of bushels of corn that come off of farms. Right? We still use bushels, pecks, gallons, dry quarts, and dry pints. You may find berries that are sold to you in dry pints. You may find strawberries sold in dry quarts. You may be able to find a half peck bag of apples still. I'm not sure where this one came from, but there's a picture. But these units are a little bit odd, at least compared to the metric system, but we can use them to try to find an answer to the particular question. So we're given these things, right? So we're given that 4 pecks equals 1 bushel, and I can use this information to figure out how many dry pints are in 2.5 bushels of raspberries. And I'm going to do the same thing we did before, and I'm going to piece together all these fractions that represent these relationships so that I can then end up getting to the correct unit. So I'm always going to start with what they gave me in the question. So I have 2.5 bushels of raspberries. I want to make a fraction out of this, and I want to multiply by the next fraction. So I need to get somewhere, so I have to think about this. I have to think where I'm going. So I have bushels. The only thing I can get to is to pecks. So I'm going to use that relationship of bushels to pecks, and I can arrange this into a fraction. It will be the equivalent of multiplying by 1. I can arrange it in a fraction. So I can arrange a fraction of 1 bushel is equal to 4 pecks. My unit of bushels will cancel, and now I'm in units of pecks. I could solve it here, but I'm going to keep going. I can multiply by another fraction, and I know that 1 peck is the same as 4 gallons. So now my units of peck have canceled, and I'm left with gallons. I want to get from gallons to dry quarts, so I can look at my relationships. I know that 1 gallon is the same as 4 dry quarts. My gallons cancel, and I can multiply now by my last relationship, which is going to be the number of dry pints in a dry quart. So I know 1 dry quart is 2 dry pints. And mathematically, all I want to do now is multiply. So I can multiply across the top. I can have 2.5 times 4 times 4 times 4 times 2. And multiply everything across the bottom, 1 by 1 by 1 by 1 by 1. And now I can get out my calculator and plug this in. And what am I going to have? 20, 80, 160 or so. My units will be dry pints. Okay, important thing. Notice that each fraction I multiply by only represents that relationship. This fraction represents the relationship between 1 bushel and 4 pecks. Okay, so this is the strategy. This is the strategy that we're going to use. We're going to use multiplying by fractions, and we can cascade these across a page to change any unit that we want into anything else, as long as we know the relationship between these, or there's a path of relationships that gets us there. Okay, so last example I'm going to do is classic example of changing miles per hour into meters per second. Miles per hour, that's what we have in our speedometers. And oddly enough, it's what the British use. Even though they're mostly metric, they still put miles per hour as their speeds and speed limits. And we want to convert this into meters per second to figure out how fast something is going. So this guy, oddly enough, this guy pictured here can go at 55 miles an hour. Must be scary, right? But we'll need some conversion units. So I've given you these here. So we know that 1 mile is equal to 5,280 feet. We know there are 3.28 feet in a meter. We know 1 hour is in 60 minutes, and 1 minute takes 60 seconds. These are the relationships that we can use to solve this particular problem. Again, where am I going to start? I'm going to start with what they've given me. Okay, I'm going to start with what they've given me. So I'm going at 55 miles in 1 hour. And the setup to these problems is everything. So if you set it up correctly, it really becomes easy. Okay. MPH, miles per hour. That means in 1 hour, you've gone 55 miles. If I make this into a fraction at the beginning, I can deal with my 2 units. I'm going to have to convert miles into meters. But I can see how to do this. And I have to convert hours into seconds. But I can see how to do that. So the key thing I'm going to worry about here is chasing my units so that they cancel. So I'm going to worry about the miles first. So I can use the first relationships in miles. So I know 1 mile is the same as 5,280 feet. And I know there are 3.28 feet in 1 meter. Okay, I'm feeling pretty good. So I've gotten rid of my miles. I've gotten rid of my feet. I'm at meters. That's where I want it to be for one of my units. My other unit, though, is on the bottom. But that's okay because your hour starts on the bottom. So you can multiply this by a relationship. Just worry about having your units cancel. So my hour is on the bottom here. So I want to make sure my hour is on the top here. So 1 hour has 60 minutes. And 1 minute has 60 seconds. My hours cancel. Remember, this is a fraction. It doesn't matter this far away. They're all multiplied together. One's on the numerator, one's the denominator. They still cancel. And I'm left with meters and seconds. All right. So now I can multiply this across. I can have 55 times 5280 times 1 times 1 times 1. And divide this by 1 times 1 times 3.28 times 60 times 60. And when I plug this into my calculator, I come up with 24.59 meters per second. Again, importantly, notice what I've done here. So I've made everything into fractions, and I've arranged my fractions so that units cancel, and each fraction only represents one conversion. So my conversion from feet to miles, I've used one fraction. It has nothing to do with what I started with. Okay, importantly, at the end of this, I'm afraid you still have to think about your answer. Does your answer seem reasonable? So if you've made a mistake someplace, oftentimes you can catch this at the end where you realize that the answer that you come up with is not in the realm of possibilities. So if you're trying to calculate, if you're trying to convert kilograms to grams, you should end up with something that's bigger than what you started with. If you're trying to convert milligrams into kilograms, you should end up with something that's much smaller than what you started with. So take a minute and think about what you got at the end. Second thing, make sure you end up with the correct unit. So every number that you report in science class should have a unit associated with it, and check to make sure you ended up with the correct unit. So if you have a unit of mass, it should be grams or kilograms. If you ended up with velocity, it should be meters per second or something related to that. And if you ended up with a unit of volume, it should be liters or something related to volumes. But you shouldn't have grams representing volume, and you shouldn't have meters representing velocity. Lastly, check to make sure all the other units canceled correctly. So you may get to the right unit, but if you've not canceled things correctly, you won't get the right answer. Okay, so I hope that you can now distinguish between numbers, units, and direction. Knowing that all three of those go together, you should be able to convert between units. You should now have a strategy to convert between units using these relationships. Lastly, you may understand what I've told you, but this doesn't mean that you can do it. So like anything in science, you need to give some practice. I encourage you to Google some worksheets or some practice problems, and a lot of answers can be found too. You can check your work that prove that you can do what you think you know. Thank you.